Okay, so here is the rest of lecture 2. So we talked, I think in class, about variable types, and in Python it's doing a service where it automatically determines the variable type. In C it does not do that for you. And so we saw one example with int, which is for an integer, and we're going to use just integers for now. Next week I'm going to talk more about data and memory, and we'll talk more about different types then, like floating point and so on. So for now, the only variable type we'll be using is the int type. Okay, so some more on functions in C. So as you'd expect, you can define your own functions. And so again, here's the same format that I'll use throughout the term. I have the cat function, so I'm in a shell. I use the cat function. Cat will display the contents of a file, so it's displaying the contents of the file function.c. Here's this hideous line that we're ignoring for now. And then we've got two functions, our own functions, foo1 and foo2. They both are declared to return integers, and so that's a hint we need to give the compiler that we didn't have to do in Python. And foo1 is returning 3, and foo2 is returning 4. And then in our main function, we're using printf again, and the argument to printf is the product of foo1 and foo2. So we're calling foo1 and foo2 with parentheses. Then we go ahead and compile it with the GNU compiler. It generates a binary called a.out, and when we invoke it, we invoke the a.out in the current directory with the dot, and when we do that, it prints 12. So here's the purpose of this slide is to emphasize the notation, the grammar for functions. Okay, so every function has its own scope, and variables live within that scope. So here's an example called scope.c, and we have a function called foo1, and it makes a variable called x, and it returns x. And in main, if we call foo1 and we take its return value, which is returning the value of x, which is 3, and we assign that to y, and then we try to print x, we get, for us, our first ever compiler error. So the compiler says that on line 12, which I can tell you right here, this is line 12, it says it's an undeclared identifier x. So it's saying you're telling me to print the variable x, but I don't have an x, and the scope for this function has nothing to do with the scope for this function, even though we call that function, and so the compiler gives up. It says there was an error, no a.out was generated, and so you'd have to go and fix the compiler error to if you wanted to actually get the compiler to work and generate a program. And in this case, presumably what you'd want to do is be printing y, because that's the variable that lives within the scope of this function. You can also actually add more curly braces within a function to affect variable scope. So curly braces create scope. So we use curly braces to start and stop functions. We'll use them in other spots as well. And I'll show you an example of that in a few slides. But here we have a variable y, and we have a variable x, and you see we've added extra curly braces in between, and when we try to print x, we again get a compiler error because x lives within this scope of these curly braces, and we're trying to print it outside the scope of that variable. Okay, so how do we do iteration in C? So there's multiple constructs. I'll lecture here on for and while. And so this is using while, and so I made a file called while.c. And I think this is pretty similar to Python syntax. So I have a variable x that's an integer, and I say while x is, and I initialize it to 0. I say while it's less than 83, I'd like to make it be 5 bigger. And then when it's done, I say print the value, and I compile it and run it. And so start at 0, and then 5, and 10, and 15, and so on. Get to 80, that's still less than 83, and add 5 and get to 85, and so that's what it prints out. Okay, so now it's going to get tricky. Let's go. So here is, I've modified the program, and I said x is 0, and I'm saying while x is less than 8, and then I'm adding 5, so I have x plus equals 2, 5, x plus equals 2, and a print statement. So I think that if you're bringing a Python spin to this, you're going to get an answer that is not what you'll get in C. This would have played out better with an audience. I'll just tell you what I expect you would have thought is we would have added 5 and then added 2. 7 is less than 8. Do it again. Another 5, another 2. And we'd print 14. That is not what we're getting. We're actually getting 12. And the reason why is that this rule of indentation that applied in Python means nothing to C, which is actually why we need the curly braces. It works differently. The curly braces show the equivalent of indentation in Python. And so this would, the while loop, if you don't add extra braces, the while loop will only apply to the very first statement that follows it. So this is saying x is 0, okay, add 5. 5 is less than 8, so add another 5. So now I've gotten to 10, and then this right here, it's indented. So with your Python background, you would think it would go within the while loop, but it doesn't. It actually goes back at the, if you think of it in Python terms, it would go at the same level of indentation as the while. And the reason the x plus 5 is within the while is because the first statement that follows is automatically within the while. And if you want it to be multiple statements, you need to add curly braces to make that happen. So let's look at some other examples. This was much better animated than it is now. Move that out of the way. So in the example on the left, we have it the exact same program, but we remove the indentation. It still produces 12, and that is what you guys probably would have written if you were writing it in Python and were trying to implement what the C program actually did. Because again, indentation means nothing to C. It's just the first statement following the while is the one that's within, that the while loop is the loop for the while loop. And so this one right here solves that problem by using curly braces. And so now both of these statements are executed within the while loop. And so this one does what you would have expected it to do with the Python indentation, where we have 0, we get 5 and 2, 7, and 5 and 2 again, and we get 14. And again, here was the original program that I showed. And then here's a new program where it's showing that indentation means nothing. This is not a compiler error. In fact, I could have put these even further to the left. X equals 0, while x is less than 8, and it still prints 14. So indentation is just not a thing for C. It's all done with curly braces, and curly braces show, you know, they're used to create scope. They're used to put multiple statements within a while loop or a for loop, which I'll show you next. Okay, so how does a for loop work? There's 3 main components to a for loop: initialization, termination, and then what do you do each step. And I guess actually there's 2 things that you do each step. One is the statement the for loop is executing, and then one is there's an extra thing that it does. And perhaps that doesn't make a lot of sense, but it will when I show you an example on the next slide. So these 3 components are often used with a loop variable. And so my example variable is I. You'll see int I used continuously throughout C. So for initialization, you might assign I a value of 0. For termination, you may say, well, I is less than 10, you want to keep going. When it's bigger than or equal to 10, you want to stop. And then what do you do each step? You increment I. So I'm just going to go forward to the next slide because I think it's going to make a little more sense now. Here is a for loop in practice. So it's calculating a sum. We initialize the sum variable at 0. We have a loop variable I. And then we have our for loop. And this says initialize I to be 0. Keep going as long as I is less than 10. And every time you go through the loop, and here's our loop right here, then increment I by 1. And so here in the loop, every time we're saying sum equals sum plus I. So the first time it's 0, and we're saying the sum is 0 is equal to 0 plus 0. The next time through, I is 1, so we get the sum is equal to 0 plus 1. The next time is 2, so we get the sum is equal to 1 plus 2, which is 3. And then 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15, and so on. And eventually we'll get to, at I equals 9, we'll get that 36 plus 9 is 45. And then when I equals 10, this will no longer be true, and it will stop executing. and so it would print the last value it had, which was 45, was the last sum that was calculated. So these for loops come up a lot. Again, this is something to initialize. Typically a loop variable, it doesn't have to be a loop variable. You can actually put a variety of statements in there. This is saying continue as long as this is true. And this is saying an extra operation you do every loop. And so you'd come in, you initialize it to 0, you'd execute this, you'd increment, check the condition, and keep going and going and going. Okay. There's a handy operator in C, which is the plus plus operator. It will increment, it will make an integer 1 larger, and then minus minus is a decrement. So here we've initialized the x variable to 0. We call the increment operator, it's 1. Increment again is 2. And then decrement, that brings it back to 1, and when we print it, it's 1. So if you've ever wondered why there is a C++ and not a C++, there is no C++, it's a pun, a word play on this increment operator, that C++ is C incremented, 1 better. And the reason it's plus plus is because the plus sign is used elsewhere, and they couldn't, I assume, construct a valid grammar if they were just saying C plus to be an increment operator. Okay, so the reason I showed that is because you'll often see for loops using this increment operator. This is the exact same program, except for before it said I equals 0, that's the same, I equals 10, that's the same, but before it said I equals I plus 1. And now you can say I plus plus, and that does the same thing. And so this is the more standard way you'd see a for loop put together, that if you're incrementing a variable, it would use the increment operator. Okay, so we've done enough C now that you can write a program, and program 2A is to find the primes between 5 and 100. And so here's the correct output, and so it shows you all the primes between 5 and 100 formatted a specific way. It's important it's formatted that way, and there's a separate post by me how you can difference the output of your program against the correct output that I posted. Other stuff, let's see, it's due on Tuesday, October 2nd. Of course, that means the night of October 2nd. I'll let you spill all the way over till 6 a.m. the following morning, which is Wednesday, October 3rd. You want to write a C program that finds prime numbers between 5 and 100. Your output should be exactly the same as mine. If the difference program shows any difference, you will get less than half credit. So I really value correct answers. I'd rather have a correct answer late than an incorrect answer on time. If you hand in incorrect work, you should expect to be getting less than half credit, because you could get half credit by handing in the right thing late. What do you upload? You just upload a single file, which is your C source code. And all this stuff about differencing, there's a whole separate YouTube post on it. It's only about 2 minutes, and I encourage you to check it out. So for me, what were the constructs I needed to get this to work? I needed for loops. I needed to use printf. I had to use the modulo operator, which is the percent sign in C. And so it's the remainder from a division. So 5 modulo 2. 5 divided by 2 is 2 with a remainder of 1, so it returns that remainder of 1. And I also had to use assignment equal, which is a single equal sign, and comparison equal, which is a double equal sign. So hopefully you're all familiar with that from languages you've used before, that the single equal sign will, if you say x equals y with a single equal sign, it will assign the value of y to x. But the double equal sign does a comparison, and it returns 1 if x equals y and 0 otherwise. And I had to use both the assignment equal and the comparison equal to do my project. So that's all I had. I wish you guys all the best on Project 2A. I will have office hours on Monday, and we'll be happy to take programming questions then. And of course, Viet has office hours on Friday, and he can help you as well. Okay, happy